How's it going, everybody? So today we're going to be looking at the square root method. Now, the use of the square root method is kind of a take on performing the AC method, but just a lot quicker. The idea is that we perform it when the b value is equal to 0, okay? And so looking at here for the number 1, you'll notice that the a value here is going to be 1. B is 0 because it's non-existent, but then the C is equal to -9. So in this instance right here, I would say, the AC method could be, done, but the square root method would be easier because all we have to do is understand how to get rid of the squared. Now I'll show you. So the idea, of course, when solving for any variables, you want to get it by itself. So we're going ahead and we are going to move over the -9 first by adding 9 to both sides. So by adding 9 to both sides, we have x squared is equal to 9. Now, here's the trick, is all you have to do in order to get rid of a squared is you have to perform its reverse operation, which is the square root. You do the square root on either side, and you get x is equal to, and your calculator can help you out too, square root of 9 is 3. Now, the only thing to remember, and the thing the calculator will not tell you, is that there's a thing called plus or minus. Now, the reason for that is because +3 or -3 actually does work for this solution. Like if you were to plug this back into the original equation up here, whether it was +3 or -3, it would still satisfy the equation and give you a 0. Because 3 squared is 9, and 9 minus 9 is 0. -3 squared is still +9, and then 9 minus 9 is 0 again. So as you can see, no matter what, you'll still get the same answer. Now, number 2, same process. The b value is noticeably 0, so we're going to add 144 to both sides, and we're going to do x squared is equal to 144. Now, the reverse operation of the squared is the square root, and then there you go. You can type that into the calculator, or hopefully you have maybe that one memorized. The square root of 144 is 12. Now, remember, the only thing to remember is the plus or minus. And so this right here is our answer. Now, a lot of people mistake this as one answer, but this is actually 2 answers. The idea is that I have x equals 12 and x equals -12. So just keep in mind that plus or minus is just a way that we like to kind of condense it down and not having to write the word and or anything like that. We just use plus or minus. It gets the point across that, you have both. Number 3, a little bit more rigorous, I suppose. All you have to do here is subtract 8 to the other side. And so that'll give you a -2x squared is equal to -8. Now, prior to taking the square root, we need to address the -2 that's next to the x. In order to get rid of it, we're going to divide by -2 on both sides. And so that'll get rid of it, and you have x squared is equal to, now -8 divided by -2 is a +4. Now you may take the square root once it is by itself, and so there we go. X is going to equal 2, but don't forget your plus or minus, okay? Because it could equal +2 or -2, or I should say and -2. Alrighty, so that right there is numbers 1, 2, and 3. And this addresses the situation where when we're working with not squares, but quadratics, and the b value is 0. So keep that in mind, okay? Now, number 4, 5, these right here are some other instances where we can use the square root method aside from using the AC method. This instance right here, you'll notice that it's really not in standard form. And that's a big indicator when you could also use the square root method when something or quadratic is not in it. This resembles more maybe the vertex form, if you can kind of remember what that was from. Remember, the vertex form was the whole y equals, let me get my pencil, the ax minus h squared plus k. That would be a good time to also use the square root method, okay? But looking at this right here, you'll notice to get to the inside of the parentheses, we have to first address the squared, okay? And so in order to get rid of the squared, it's still the same process. We're going to take the square root on either side. And these will go ahead, reverse operate, and it'll get rid of the squared, and you have x minus 6. And the square root of 25 is 5, but plus or minus. Now, It's important to have plus or minus for this very moment because we still got to get the x by itself by adding 6. So by adding 6 to both sides, you have x is equal to 6 plus or minus 5. Now this is interesting. Now, how do we use this? How do we operate on this? Because there are some people who will just box this in and they'll be like, that is the answer. But to be more precise, the way you handle this is x could be 6 plus 5. And x could be 6 minus 5. Now, of course, we should simplify that now. 6 plus 5, that is 11. Oops, sorry. And then 6 minus 5, that is indeed 1. And so now you can kind of see that, you know, the plus or minus is important, and it's good to have that habit created because there are going to be instances where you will have to go ahead and figure out, you know, what will it be if I add 5 or subtract 5. And I think we're going to see the same thing for number 5 as well. So let's take a look at it. So here, once again, we're going to go ahead and need to get rid of the squared. So we're first going to take the square root. And so that's going to give me x minus 4 is equal to plus or minus 7. Then, of course, we're going to add 4 on both sides. And that's going to give me x is equal to 4 plus or minus 7. And we should go ahead and always make a point to further simplify that. So x, 4 plus 7, that is also an 11, conveniently. And then 4 minus 7, that's going to be x equals a negative 3. And then there we go. So those would be our 2 answers for number 5, okay? Now let's go ahead and take a look at these, okay, right here. So this is simplifying the inside of a square root because there are going to be times where you may take the square root, but it gives you a decimal. It doesn't come out to be a pretty whole number. And what we like to do in academics for math is we like to simplify the square root, but not into a decimal. We like to try to figure out what can we take out of the square root. Now, this may have been taught to you before. I'm going to teach it from the perspective of the factor tree. And I will demonstrate that now to kind of give you an idea of what I mean by the factor tree. So first things first, let's try to get the x by itself. We're going to add 31 to both sides. And so we have 49 plus 31. And so that's going to give me an 80. Yeah, so I have 80. And then I have 4x squared minus, oh, we already got rid of the 31. I just have 4x squared. Now, before I can go ahead and take the square root, I need to go ahead and divide by 4. So let's divide by 4. And so then I have x squared is going to equal, now 80 divided by 4, that's going to give me 20. And voila. Now let's perform the square root on both sides. And x is going to equal the square root of 20, plus or minus, right? Now we have to understand that we don't want to leave it like that because we could simplify it with the factor tree. And the factor tree is as follows. You're going to take the number that's in the square root and just ask yourself, you know, what would break apart 20, like into multiples? What two numbers give you 20? Well, you could do a 4 and a 5, right? And you could also do other variations of it. You could do 2 and 10. And what's nice is no matter which one you choose, it will work out the same. And I'll make sure to show that as well. So here, if I did the 4 and the 5, I have 2 and 2 because the 4 can break apart again into 2 times 2. Now 5 is a prime number and cannot break up any further. So we'd leave it like that. 20 breaks up into 2 and 10, and we could have 2 and 5. Now, if you'll notice, the ends of my tree have the same numbers. So as you can see, no matter which number variation you choose, you'll end up at the same spot. Now, in order to leave a square root to simplify, you need to be able to find 2 of a kind. Now, the 2 of a kind in this scenario right here is my 2's. Right? from both examples, it's the 2's. So the idea is the 2 is going to go in the front of the square root. So I have plus or minus 2 square root. Now, what's going to go back inside, though, is my lone number, okay? The number that does not have a pair, and it's going to be my 5. And so that right there is my answer. Now, please keep in mind, this represents x equals, 2 square root of 5, and x equals negative 2 square root of 5, okay? And there you go. Now, let's go ahead and take a second and look at number 7. Let's kind of get that out of the way. Alrighty, so for this one right here, what we're going to need to do first is we're going to need to move over the 2, okay? So we're going to subtract the 2 on either side. And I have 4x minus 1 squared is equal to, now 98 minus 2, that's going to be a 96. And then I'm going to go ahead and need to get rid of the 4 before I take the square root, okay? So let's go ahead and do 96 divided by 4, and my calculator says that's 24. So when I do this, that's going to equal 24, okay? Now, the next thing we're going to need to do is we're going to need to take the square root on either side. And so that's going to go ahead and give me x minus 1 is equal to the plus or minus the square root of 24, okay? Now, the next part that we're going to need to do is get the 1 to the other side by adding 1. So we're going to add 1 to both sides. So I have x equals 1 plus or minus the square root of 24. Now keep in mind though, 24, that could simplify inside. So let's take a look at it. So I got 24. That could be 6 and 4. And I could break up 6 again too. I could break it up into 3 and 2. And I could break up the 4 into 2 and 2. Now remember, in order to leave the square root, we need to go ahead and have 2 of a kind. Now in this scenario right here, the only set of 2's I have, I could pick these 2. But then I'm still left with a 3 and a 2, okay, who do not have a buddy. So the way that's going to work is you're going to have yourself an x equals 1 plus or minus. Now the blue circle, the one that has a pair, comes outside, so you have a 2. But then the 3 and the 2 have to stay, okay? The ones that are circled in green. Now, of course, you should simplify that. 3 times 2 would give you a 6. And so that is what's going to remain inside of the square root. And that, ladies and gentlemen, is your answer. So the idea is you have your x equals 1 plus 2 square root of 6. And you have x equals 1 minus 2 square root of 6. Alrighty, ladies and gentlemen, that is the process for using the square root method to solve for the quadratic equations, x-intercepts, roots, solutions, pretty much any name that's out there for them. That is the process. So good job, everybody. Let me know if you have any questions, and see you tomorrow.